Hello and welcome to 11.2 Calculus with Parametric Curves. Today we're going to be looking at, first of all, there's a bunch of things we'll be looking at. We're looking at first derivative, looking at second derivative of parametric curves, we're looking at area underneath the parametric curve, arc length, surface area, there's a whole bunch of things. So let's start with the first one. So we have the first derivative, dy dx, is defined as dy dt over dx dt. And if you do the division, dt's cancel, you're left with dy dx. Okay, so an application of this is to find the tangent to the curve. Okay, so we have the parametric curve with x equals y equals in terms of t. And we want to find the tangent to the curve at the point radical 2 comma 1, where t is pi over 4. And we have a figure on the right here to show what we're looking at. Okay, so let's take a look. We got the first one. So we need, in order for a tangent, we need to figure out the derivative, right? So we need to figure out dy dx. So dy will be dy dt, dx will be dx dt. So dy dt, so we're taking derivative of tangent. Derivative of tangent of t would be secant squared of t. Derivative of x would be, so derivative of secant would be secant tangent. So secant t tangent t. And then we could cancel out one of the secants from top and bottom. So we're left with secant t over tangent t. Okay. So to figure out what this is at t equals pi over 4, that's the next piece. We want to figure out what is dy dx when t is equal to pi over 4. Okay, so what would that be? So if we do this, that would be secant of pi over 4 over tangent of pi over 4. Secant of pi over 4 would be radical 2. Tangent of pi over 4 would be 1. So we have radical 2. Okay, so that's our slope. Okay, so now to get the tangent line, right, equation of the tangent line is just like getting the equation of any line. We're going to be using our classic point slope form, y minus y1 equals mx minus x1. So we know what the slope is, which is radical 2. We know what the x and the y is. They gave us an x and a y here. Right? This was x, this was y. You want to call it x1, y1 for the sake of our equation. That's fine. So that means we would have y minus 1 equals radical 2 x minus radical 2. Okay, and that means we can distribute the radical 2. So that would give us radical 2x minus radical 2 times radical 2 is 2. And then last step, we can add 1 to both sides. So that means y would equal radical 2x. Negative 2 plus 1 is a negative 1. Okay, and that would be the equation of the tangent line. And we use the first derivative to get there. Okay, next they want us to figure out the second derivative. So now the way we do a second derivative is we take the derivative of the first derivative for y, so second derivative for y, over dx dt. So dx dt is the regular derivative for x. Okay, so we have a problem here. So let's find the second derivative as a function of t if x equals t minus t squared and y equals t minus t cubed. Okay, so let's get the first derivative for y. So dy dt. In fact, let's do this first. Let's get dy dx, because keep in mind we're going to do that first, right? So dy dx and y prime is equal to dy dx. So first we're going to do y prime in terms of t. So we're going to do dy dx. So we'll do dy dt over dx dt. So that means for dy dt, that would be this one. That would be derivative of t is 1. Derivative of t cubed is 3t squared. So 1 minus 3t squared. Derivative of x, so we go to the x equation. Derivative of t is 1 minus derivative of t squared is 2t. Okay, so this is dy dx. So this is equal to our y prime. Okay, so that's the first step. Next step we want to do is differentiate this y prime with respect to t. So we want to take the derivative of what we just found with respect to t. Okay, so we would call this dy prime with respect to t. Okay, so if we take the derivative of this, this would be, what would this be? A quotient rule. So we would have denominator 1 minus 2t times the derivative of the numerator. Derivative of the numerator would be negative 6t, right? 2 times negative 3, so negative 6t minus numerator 1 minus 3t squared times the derivative of the denominator. Derivative of the denominator is negative 2 all over denominator squared. Okay, we could simplify this. So here, if we distribute the negative 6t in the first parentheses, we have negative 6t plus 12t squared. Negative 2 in front, that would make it a positive 2. So it's plus 2 minus 6t squared. Okay, denominator is still 1 minus 2t squared. Okay, simplify the top. We have 12t squared minus 6t squared, so that's 6t squared minus 6t plus 2 over 1 minus 2t quantity squared. And then to continue, we need to take this dy prime dt and divide it by dx dt. That would be the last step. So to get the second derivative, we would take dy prime dt and divide it by dx dt. Okay, so we already have 6t squared minus 6t plus 2 over 1 minus 2t squared. And we're going to divide this by dx dt. Now we found dx dt is 1 minus 2t. Okay, so keep that in mind. dx dt is 1 minus 2t. So if we're dividing by that, we're multiplying by 1 over the 1 minus 2t. Okay, and that means we could simplify this. The top part will stay the same. And then we have the bottom. We just combine them and say 1 minus 2t cubed. And then that would be the final answer. So that's the second derivative. Okay. The next piece is we're going to figure out the area underneath the curve, underneath the parametric curve. Okay, and this will be the setup for area. We're going to take the integral. Our bounds will be from alpha to beta. Now these are the bounds for t. So I just wanted to point that out. Usually we go from a to b when we're dealing with x or any other variable. But because this is all based off of t, we go off of our bounds for t. Okay, so t is between alpha and beta, and this will be the setup. Okay, this setup comes from our it just comes from our f of x dx, if you will. Another way to write f of x would be y, and another way to get dx is if we take the derivative of x. Okay, so when we're doing these types of problems, we designate one of the variables, the x. For example, x equals, that'll be our f of x or f of t, and our y equals, that would be our g of t. Okay, so let's do a problem. I'll show you guys with an example. So we have x equals t squared, and then y equals 4t squared minus t to the fourth. And t is going to be between 0 and 2. Okay, so let's first take a look at what this looks like. Let's make a graph. Let's make a table of it. T, x, and y. Okay, so we have t is between 0 and 2, so 0, 1, 2. Let's plug in 0 for t, so x is 0. Plug in 0 for the t's in the y, so that gives us 0. When we plug in 1, 1 squared is 1. When we plug in 1 in here, we get 4 minus 1, which is 3. When we plug in 2, 2 squared is 4. And when we plug in 2 in here, 2 squared is 4 times 2 is, let's see, 2 squared is 4. 4 times 4 is 16. 2 to the fourth is 16. So 16 minus 16 is 0. Okay. So let's graph it. So we have 0, 0. So we have 0, 0. 1, 3. 1, 3. 4, 0. Okay, so notice we have this little gap here. We want to get a better picture of what this is going to look like. Right now it almost looks like a triangle. Okay. So when we see this gap, we could try to figure out backwards, like what's happening when x is 2, what's happening when x is 3. Okay, so when that's the case, a common technique is we go and we work backwards. When x is 2, when x is 3. Okay, so when x is 2, we plug in 2, so that gives us 2 equals t squared. That means t would equal square root of 2. Okay, so when we do square root of 2, and we plugged in, we would get 4. Okay, do the same thing with 3. 3 would equal t squared. So that means if we take the square root, t would equal square root of 3. So square root of 3. And then we plug in square root of 3. Square root of 3 squared is 3. 3 times 4 is 12. We get 12 minus square root of 3 to the 4th. That would be 3 times 3, so that would be 9. So 12 minus 9 is 3. Okay, so that allows us to fill in these other points. 2, 4, and 3, 3. Okay, so it actually is like this. And then we're going to try to fill in, figure out the area underneath the curve. Okay, so we're going to use the formula here. So like I was telling you guys earlier, the x equals, that's going to act like our f of t. And the y equals, that would be like our g of t. So when we're using this formula, we're going to use g of t the way it is. So that's the 4t squared minus t to the 4th. And then the f prime of t, that means we take the derivative of our f of t function, just t squared. So we'll get 2t. Okay, so we'll do the integral from 2 to 0. That would be our alpha and our beta. Okay, so let's see how this would look. 2 to 0. And then we have 4t squared minus t to the 4th times derivative of f was 2t dt. Okay, distribute the 2t into our parentheses. So we have 8t cubed minus 2t to the 5th. dt. Okay, so now we can integrate this. So when we integrate it, we have 8t to the 4th over 4 minus 2t to the 6th over 6. And we're going to evaluate this from 2 to 0. Simplify it a little bit, we get 2t to the 4th minus 1/3 t to the 6th. And then we plug in. So we have 2 times 2 to the 4th minus 1/3 2 to the 6th. And then when we plug in 0, we just get 0. Okay, so 2 to the 4th is 16 times 2 is 32. 2 to the 6th is 64. Times 1/3 will be 64 over 3. Okay, so that means if we get a common denominator of 3 over 3, that means this will be 96 over 3 minus 64 over 3, and that would equal 32 over 3. And that would be our answer. Okay. That's area under a curve. Next, let's do a length like an arc length, if you will, of a parametrically defined curve. So this is the formula for a length of a parametric equation. Okay, we take dx dt, square it, dy dt, square it, add them together, put it under the square root, take the integral. And that's how we would do it. Let's do an example to start us off. So let's say we have x equals 8 plus 6t squared. And then y equals 1 plus 4t cubed. And t we're going to be defining between 0 and radical 8. Okay, so that means dx dt, let's get that first. Dx dt would be, the constant would go to 0. 2 times 6 would be 12, 12t. dy dt, again the constant goes to 0. 3 times 4 is 12, so 12t squared. Okay, so let's set up our integral for the arc length. So this would be, we're going from 0 to square root of 8, so square root of 8, 0, square root dx dt, so that's the 12t squared, plus dy dt, 12t squared, squared, and then we have dt. Okay. So underneath the radical, simplify this. 12t squared would be 12t times 12t, which is 144t squared. And 12t squared, that's being squared, that would be 144t to the fourth. Now, one of the things we could do here, we could factor out, right, a common factor. So between the two terms, we could factor out 144t squared. Okay, and then we can split apart our radical. So we have the square root of 144t squared times the square root of 1 plus t squared. So square root of 144t squared will be 12t. And then so we have 12t, and then this part I have inside the square root. I'm going to write that as to the 1/2 power, because I'm getting ready to integrate it, right? So when I integrate this, I could do a little u substitution. My u would be, I forgot the square there. My u would be 1 plus t squared. My du would be 2t dt. So here I have 12t. That's 6 times what I have for my du, right? Okay, so if I want to think about this, I'm going to go in generic terms here. 12t is 6 times 2t, right? And I have the 1 plus t squared to the 1/2. Okay, so that means I could pull the 6 out, and I have u to the 1/2, and with the 6 and the dt, I have, no, with the 2t and the dt, I have my du. Okay, so now if I integrate this, that would be u to the add 1, so u to the 3/2. So that would be 2/3 u to the 3/2. Okay, now when I simplify that, the 6 and the 3 cross cancel, divided by 3, so 2 times 2 is 4. So this gives me 4u to the 3/2. Okay, so I'm going to plug back in. So I have 1 plus t squared to the 3/2. And I'm going to evaluate this from square root of 8 to 0. Okay, so if I plug it in, 4 times 1 plus, now square root of 8 squared is 8. Okay, minus 4. When I plug in 0, that gives me 1. So now here I have 9. The square root of 9 is 3. 3 cubed is 27. And then here square root of 1 is 1. Cubed is 1. So here I have 54,108 minus 4, which gives me 104. Okay, and that would give me the length of that parametric curve. Okay, let's take a look at, let's see, what do we have here? Area of surface of revolution, so surface area. Okay, so we have two typical formulas for this. You'll notice there's one version with revolution about the x-axis and another version with revolution about the y-axis. Okay, so let's do an example. Okay, we got standard parametrization of the circle of radius 1 centered at the point 0, 1 in the xy plane is, okay, and they give us the equation for that. Okay, x equals cosine t, y equals 1 plus sine t, t is between 0 and 2 pi. And they want us to revolve this curve around the x-axis. Okay, we want to revolve the circle about the x-axis and find the area of the surface. Okay, so I put the formula here as a reminder of what formula we're going to be using. Okay, so let's go through it step by step. Okay, let's first figure out dx dt. So dx dt, derivative of cosine is negative sine, so negative sine of t. dy dt, would be, well, derivative of sine, right, really, because 1 is 0. Derivative of sine is cosine. So we have cosine of t. Okay, and if we're following this, we have integral. This would be from 0 to 2 pi. And the formula is 2 pi times y, so 2 pi. Y is 1 plus sine t. So 1 plus sine t times the square root. And let's plug in our dx dt and our dy dt. So that would be dx dt, so that's negative sine t squared plus cosine t squared dt. Okay, so we got it all set up. Now we got 2 pi 1 plus sine t. We're going to simplify underneath the radical. So negative sine t squared, negative sine t times negative sine t would be just sine squared t. And cosine t squared will be cosine squared t. And so what do we know about sine squared plus cosine squared? Is equal to 1. Right? And the square root of 1 is 1. So we're really down to what we have here. Right? So the 2 pi I'm going to pull out. It's a coefficient. So I have 1 plus sine t dt. Okay, I'm going to integrate this. So this will give me, I have 2 pi. Integral of 1 is t. Integral of the sine t is negative cosine t. And then I will evaluate this from 2 pi to 0. Okay, so that means if we plug this in, 2 pi that means we have 2 pi minus cosine of 2 pi minus 0 minus cosine of 0 well, cosine of 0 is 1. So here we have 0 minus 1. So I have negative 1. And then here I have 2 pi minus, now cosine of 2 pi would be 1. Okay, so I have 2 pi minus 1. Now I have a minus 1 minus a minus 1, so it's negative 1 plus 1. So those are going to cancel. So I have 2 pi times 2 pi, which ends up giving me 4 pi squared. And that would be the area of the surface of this revolving circle about the x-axis. Okay, if there's any questions, just write me an email. Have a good day, have a good night. We'll see you soon.